Today we're going to be talking about parallel circuits. This is a parallel circuit. It's different from a series circuit because there's more than one way that an electron can flow around the circuit. It could go this way or it could flow this way. Like last time, we're going to look at how current and potential difference change in a parallel circuit. So let's turn the circuit on and let's start with current and our ammeter. Okay, so putting our ammeter in here, we're getting a current of 0.44 amps. Let's try it out somewhere else. Putting it in here, we're getting a current of 0.19 amps. Let's break apart the circuit here and we'll put our ammeter in over there. And over here, 0.20 amps. So we can clearly see that the current isn't the same everywhere as it was in our series circuit. So why is that? Well, in a parallel circuit there are different loops through which the current can flow. As the current gets to this point, it will split, some passing through one loop and the rest passing through the other loop. If the resistance of the components is the same, then the current will divide equally between the two loops. If they're not, the current will flow fastest through the component with the least resistance. Therefore, if the current here is 8 amps and the bulbs are identical, then it will divide into 4 amps here and an identical current of 4 amps here. The current will then rejoin to get back to the original current of 8 amps. So the rule in parallel circuits is that the current in the branches adds up to the total current. Or put more simply, ammeter 1 is the sum of ammeter 2 plus ammeter 3. Moving on, we're going to be looking at potential difference. So let's start off by taking the potential difference across the power supply. So the potential difference across our power supply is around about 2.53 volts. If I put it over this bulb, I get 2.28 volts, and over this bulb 2.28 volts. Now we can see they're pretty close to being the same. This is because energy has to be conserved whichever path the electrons take, and so therefore the energy transferred around the circuit is always the same. Let's have a look at that in a bit more detail. In a parallel circuit, the electrons will transfer the same amount of energy regardless of which path they take. Therefore, the potential difference across the power supply, in this case 9 volts, will be the same as the potential difference across each component. So this bulb will have a potential difference of 9 volts, and this bulb will also have a potential difference of 9 volts. In a parallel circuit, the potential difference across each component will be the same as that across the power supply, or voltmeter 1 equals voltmeter 2, which also equals voltmeter 3. So there we have the rules for potential difference and current in a parallel circuit. Make sure you check out our website, the link is in the description below, where you can find more questions and extra information. Also make sure you subscribe and check out our playlist on electricity for more informative videos about this topic. Thanks for watching and happy sciencing.